Okay, so in this video, we're going to solve an example of a first order circuit. This is going to be an RC circuit because we have resistors and a capacitor in it. That's opposed to an RL circuit where you have resistors and inductors. Now, every one of these problems that we're looking for the transient response, we're going to have something that changes in the circuit. That's usually going to be a switch like it is right here. And whenever you're doing that, you're going to need to figure out what's going on before the switch happens and then what's going on immediately after the switch happens. So let's take a look here. Right before the switch happens, that means it's still in the position 1 here. We're going to go ahead and draw our circuit. And there's one thing to point out here is that since it's been in this position for a long time before it swaps to position 2, that means it's in initially steady state, which means capacitor is going to be an open circuit here. And so this is what we're going to look like. And so at this point in time, we can go ahead and figure out what the current's going to be. The current here is going to be 12 volts over 9 kiloohms. That's going to be 1.3 milliamps, or really 4/3 milliamps if you want to be more accurate. And so then we can go ahead and find the voltage here by doing I times R. That's going to be 3 kiloohms times that's going to be 4 volts. And that is what is going on in the circuit before this happens. So I can go ahead and write down that since we're looking for the voltage of this node, the voltage of that node at 0 minus, so right before the switch happens, is 4 volts. Now, right after the switch happens, it's no longer in position 1, it's now in position 2. And I'm going to draw the source here, but notice that because the switch moved from position 1 to position 2, that voltage source is not actually forming a closed circuit anymore. What that means is it's basically not doing anything anymore. And if I hadn't drawn it down, that would be perfectly fine. Now, what we know is that the voltage across a capacitor cannot change instantaneously. So whatever it was before the switch happened is going to have to be the same as it is right after the switch happens. So this right here is still going to be at 4 volts at time t equals 0 plus. And what we need to do is, since we are asked to find this current right here, we need to find the value of this current at 0. Well, it's the current going through the 3 kiloohm resistor. And since we still have 4 volts across it, that means it's going to be the same as it was beforehand. Now notice that we couldn't necessarily say the current was the same just by itself, because in a resistor, the current can change instantaneously. But since this resistor was in parallel with a capacitor, and the voltage across the capacitor cannot change instantaneously, that means the voltage across the resistor in parallel will not change instantaneously, which guarantees that our current through the resistor will not change instantaneously. So we're going to have 4/3 milliamps here. That's going to be our starting value of our current. Now we also need to know what the final value of our current is as t goes to infinity. Now we could kind of skip this because we know that there's no longer any source in our problem, and that means there's nothing to provide power, so it's eventually going to go to 0. Also, we can just draw it like this, realize that as we go to infinity, we're going to go back into a steady state, and in this case, it's a steady state with no source, and so there's nothing going on here. So that means I of infinity is 0 amps. And the last thing we need to figure out is our time constant. And there are two formulas for that. One is that time constant is R Thevenin times C. And the other possibility is the time constant is L divided by R Thevenin. So in this particular case, it is the R times C version. And so what we're supposed to do is we're supposed to find the Thevenin resistance with respect to the capacitor here. So if the capacitor becomes your open circuit and you want to find the Thevenin resistance here, because we're looking at those two terminals, the 3 and the 6 are in parallel. So my R Thevenin here would be 3 in parallel with 6. It's going to be 2 kilo ohms. And so my time constant then is 2 kilo ohms. And my resistance is 100 microfarads. So 2 times 100 is 200. Kilo times micro is milli. So that would be a 200 millisecond time constant here. Or in terms of seconds, tau is 0.2 seconds. Now we know that every time you solve a first order circuit, based on what we saw in the other video, it's always going to be K1 plus K2 e to the negative t over tau. If you plug in 0, you're going to get K1 plus K2, which you saw up there is 4/3. If we plug in infinity, e to the negative infinity goes to 0, it's going to be just K1 here. So K1 is 0. Solving for that means your K2 is 4/3 milliamps. And using the tau above, we can then write our final answer here. I of t is 4/3 e to the negative t over 0.2 milliamps. And we've solved for the current through that resistor for any time greater than 0. This is going to be our main process for solving all of these circuits. Look at before the switch happens, look at after the switch happens, look at infinity, find the time constant, and put it all together to write your final answer.